IP audio, network audio, what does that mean, and is it any different to 100-volt line, to low impedance? Where does it fit in?
So to start with audio over IP, some type of network device, you have to start with a raw audio signal. It comes in the same way into a microphone. Now, depending on what manufacturer, what brand of microphone, it can get converted there into a different type of signal, a digital signal that we can take and put on the network. Or it might go into a traditional microphone that goes into a digital signal processor, and that would change it into packets or some other type of protocol that we could send over existing infrastructure. And once it's in packets, we can pretty much send it where we want. We can do with it as we wish. There are loudspeakers now that have powered amplifiers that receive these packets and re-encode them into audio and reproduce it. Or it can go to another DSP that will de-encode it or re-encode it and reproduce it like a traditional system.
So why do we want to do this? What's the difference? What's wrong with current distributed sound via 100-volt, 70-volt line? What's wrong with low impedance?
Well, the limitations of low impedance and traditional audio is that usually it has to stay within the room or within the building. Once we exit a building and want to go downtown or to another city or across country or across the world, we really can't do that with a traditional audio system. Even very large audio systems like the telephone system have limitations. We can get cross country, but the fidelity is not quite there. With networked audio, once we change it into packets, we can send it anywhere in the world. It's an Ethernet packet at that point in time, and it can go anywhere email can go. So I can send my audio system from this room for a large all-hands meeting for a multinational company, and they can receive it all over the world at the same time. Granted, there will be some latency, but it's not going to be as bad as trying to get electrons down a speaker cable for 20 miles. It's going to be a lot more functional for very large projects. And the cost of infrastructure now is going to go down because there's not as much copper. We can send many audio signals down one Ethernet line, and it takes the place of bundles and bundles of copper. I mean, even the older protocols were doing 64 one-way, 64 another. And if you think about a 128 channel snake, that's a huge bundle of copper replaced with one category cable now and a couple boxes.
Now, we've been talking AV/IT for, I don't know, let's say 5-10 years now, and there has always been an argument as we migrate towards IP of installers saying, well, the IT is not going to let me anywhere near his network. Have things changed now?
Things have changed, and I think it's because of our understanding as audio-video professionals that now we live on the network. The convergence has happened, and this is a thing we do now. So what we're really doing is working more with the IT and the LAN professionals, the LAN managers. They have two main jobs. Network has to be secure and it has to remain up. And if they don't know what's on their network, that could jeopardize both of them. So knowing this now and knowing more about network operations and how the LAN actually functions and all the things associated with that, we can better prepare as AV professionals to work with the IT managers to make sure that we have enough bandwidth, we have enough headroom. If we need VLANs or virtual LANs, that we can set that up ahead of time. Things like we just don't show up and say, where can I plug this in? Because that could be detrimental to both security and uptime. Learning how to, months ahead of time, say, what of my system do you need to put into a development network to see what ports we need open, to see what protocols are going to happen, any security restrictions. And as we learn to work on the network more and more efficiently, I think we get more of that cooperation. We all have to live on the network now. It's just like driving on the roads, and it doesn't matter if you drive on the UK side or the American side, we all have to obey the traffic laws. So as we progress further into IT and into living on the LAN, I think our understanding and how to work with the IT professionals is just getting better, and it's developing a better relationship, and it's getting easier.
So if a conventional audio or AV installer is upskilling to add those IT skills, we still need to design an audio system. Have the rules changed? Or is designing an audio system just the same, but over a different platform?
So designing an audio system, you're always going to have to deal with physics, room physics, acoustics. Just the back-end electronics are a little bit different. We still have vibrations that have to be transduced through a microphone, get sent down a cable, processed, and then once it's processed, there's new engineering. How much bandwidth does that take up? How much am I going to put on the network? And I have to do calculations for this, for how many channels, to make sure I don't saturate the network. And then once I'm done with that, converting it back into an audio signal, into an amplifier. The physics, again, are the same as traditional audio. How loud does it have to be to get above ambient noise? How much coverage do I have? What type of fidelity do I have? So not only do we have to know the old things, but now we have to incorporate all of the network side, the engineering that goes into making a good, clean audio system through ones and zeros.
You talked about, some of the benefits of audio over IP being distance, of course, but another of the major benefits is zoning as well. The level of control available to you just increases exponentially. Explain how that works.
It does. So zoning is a great thing because we have control. The more zones you have, the more control you have over your audio. Volumes can get louder or softer per zone. We can EQ them per zone. So if we have the same audio signal going into several different areas, we can do different things with the audio, like I can reduce the volume if the ceiling speaker's lower than just having it louder in that area. The control is amazing, and with ceiling speakers nowadays being their own node, receiving their own audio channel, having their own audio amplifier, I can have amazing amounts of control. As you know, the more control, the more management we have to have, but I think the benefits of that, putting in a little bit extra up front, getting everything just right, dialed in, and being able to have that control of an individual node to give us what we want is spectacular. It's so much easier than just doing an overall EQ or overall volume and just kind of letting it be what it is, or trying to retap loudspeakers. And another nice thing is these loudspeakers with amplifiers built in are powered over Ethernet. So I don't have to run separate power cables to all my amplifiers. I can get a PoE switch, give it to 8 or 10 loudspeakers, and that's good. One cable, not a lot of infrastructure. As long as we run our cabling correctly and make sure it's all certified, everything will work out great. And not having to go up and touch that loudspeaker or that amplifier afterwards. Not having to get on a ladder and being able to do everything from a workstation. The benefits to that are amazing. Service is quicker, commissioning is quicker, getting everything tuned is a lot faster, a lot more efficient.
So I guess in a conventional analog system, great product is what it's all about. With an IP system, when you're looking for a good IP system, it needs to be fantastic product, but having a good user interface, a good control platform that makes the whole thing easy from a laptop, even from your phone these days, is a big part of a good system now.
Oh yeah, any UI is going to make or break how effective the system is. You can have a beautifully designed system, and if the user interface isn't very good, it's like not having a good steering wheel on your car. It's no matter how well your car runs, if you can't control it, if you have issues with that, it's going to be more difficult, and you're not going to want to drive that car. With a good user interface in any network system, a good user interface is paramount, and having that functionality and availability and ease of use is all about not just the experience for the client, but the experience for the programmer or for the engineer. That has to be there too. And just like the clients enjoy a good experience from the AV system, the AV providers enjoy a good user interface, a good experience from the equipment that they put in.
As audio over IP grows and grows, we're seeing installers who are considering it, but don't want to go out there and do a worldwide system, for instance. But it's not a case that if you've got, let's say, a number of disparate analog systems, it hasn't all got to be replaced. You can actually create a hybrid system. Is that right?
Sure. If you have an existing audio system and you wanted to make it a networked audio system, say in a traditional classroom or conference room, you can add a box. And there's many manufacturers out here who sell many different types of boxes that will do that and do it well. And you can integrate this box to have a goes into, an input, and a goes out, and a separate LAN that goes both ways. So I can have my traditional system, add a box, have an input going into that box, an output coming out of that box, input and output from the LAN, and now I can connect several classrooms or conference rooms together. So it's not that the old traditional system's going away, we're just adding some things to make it better, to make it more user-friendly, to get the small classroom to now be part of a larger network of classrooms to work for overflow or campus or enterprise-wide discussions or talks, and to just be a lot more functional. Audio is always going to be analog, but the way we treat it from the time it leaves here to the time it gets there, that's evolving, and that's evolving for the better.
And I guess what you were saying there at the same time is that the ideal solution for every system, this scalability to consider, really. You know, there will always be 100 volt line, 70 volt,
Sure.
maybe not always, maybe it will take over one day. But yeah, I don't think we need to try and apply it to everything, do we, at the moment?
No, we don't. It's really going to depend on your enterprise goals and your strategic vision of what you're going for. If you have one or two conference rooms and they're in the same building, no, it might not be worth the cost. The ROI might not be there to put in the cabling or to buy the new equipment. But if you have a very large enterprise or a campus that has a lot of different systems in it, a lot of different audio and video systems, things that maybe professors use, and you know they're professors of a certain art or a certain science. They're not audio video professionals, and we don't expect them to be. Managing that might really benefit from some AV over IP, being able to dial in or just listen to what's going on. If they say, I have some problems, being able to listen in from a central control room before you run out and realize, hey, the microphone's just too hot, I can turn it down from here and fix a problem instantly. So some things will benefit, some things will be the same. The traditional 100 volt, 70 volt speaker lines, low impedance speaker lines, they're not going away. But even at large rock concerts where we have fly rigs and massive amounts of speakers where there's still low impedance 8 ohm, 4 ohm loudspeakers, those amplifiers are getting fed by category cable. Those digital signal processors are, you know, it's one category cable instead of a large snake. So every aspect of audio video can be affected by this, whether it's large rock concerts or a small classroom. But the traditional system of audio video it's going to be there for a while.
And let's just talk about compatibility. Just as a warning, if we've got 100 volt line systems, we can pick up that brand of speaker, that brand of amplifier, that brand of mixer, plug them all together and they will work. Same with low impedance. Not actually the case with audio over IP, is it?
No, there are several different protocols, and some of the different protocols have their own rules. They require their own type of box. So when starting to design some type of AV over IP or audio over IP, you really want to make sure you're trained well on all of the aspects before you start designing and buying boxes and trying to stick one box with the other. And you really want to make sure that everything is compatible and protocol compatible. You can get different boxes from different manufacturers as long as they're protocol compatible. If they're not protocol compatible, we're going to have a lot of paperweights sitting there trying to get information that aren't talking to each other. So it's very, very important that the protocols are all compatible with each other. And again, there's so many manufacturers that make boxes that are protocol compatible, different price points, different sizes. The sky's the limit out there with that.
So just to round it up then, audio over IP, it's everywhere now. You will start to see it more and more. The benefits are, let's go through them again. We've got distance transmission. We've got the fact that you can use existing Ethernet cabling that's already in the building. What else have we got?
The cost. I mean, if you think about scalability of the cabling alone, those big giant snakes, that's a lot of copper, and copper costs money. And I can replace a huge, huge bundle of copper with one category cable. It's actually reduction in cost. One of the cost analysis we do in design class is designing a live audio system with 64 channels back and forth. The cabling infrastructure with conduit and everything else came out to about $65,000. When we did it over IP, the cabling infrastructure, conduit, and everything else came out to about $5,000. So the cost of the actual infrastructure, if you're reducing from a large-scale audio to category cable, is an incredible savings. So there's a cost benefit there.
Zone control, of course. We talked about zone control, and the flexibility just becomes enormous. And one thing that just popped into my head for installers is that the way that you service a system changes out of all recognition. With a conventional analog system, if you've got a service contract, you've got to go to site, let's say once, twice a year, and check that through. Every single speaker or zone on the system can now be serviced and tested from the desk.
Oh, yeah.
Correct?
Yeah, it's its own node. It's its own little computer, and you can run diagnostics on it. You can see if it's putting out signal or not. It will tell you loudspeaker impedance. It will tell you temperatures of the loudspeaker. It will give you all the information of that loudspeaker. And if there's a fault, it'll tell you if there's a fault. Even before you go out to service it, it will say, hey, something's wrong with me. I think somebody needs to pay attention, and shoot you an email. And then that reduction in going back and forth on a quarterly or a biannual visit, we really don't have to do that. We can check on the system pretty much anytime we want, and only have to go out if there's an issue. And nowadays there's not a lot of issues. They pretty much work.